All right, question number 5. We want to determine the critical value for a left tail test regarding a population proportion at the alpha equals 0.10 level of significance. So we can just use the table. We are looking for left tail, and we're looking at 10%. So I'm looking inside the table. Let's make this bigger, kind of hard to see. Second, there we go. Looking for 0.10, so 10%. All right, so right here, this number 0.1003, this is the closest. That's about 10 thousandths off, 15 to the end. This you just subtract 3. So this row is negative 1.28, negative 1.28. So we can get it from the table. You can also do this with StatCrunch. It's still dealing with the normal assumption. So if you did calculators and normal, it'd just be a backwards application. Mean 0, standard deviation 1, that is the standard normal. And you just come over here and change the area to the left to be 10%. It's going to give you that negative 1.28. So you can also work backwards from there. But that's going to be good enough for that one. And then leave that. Number 6, complete parts A through C. So we want to determine the critical values for a right-tailed test population mean at alpha equals 5, level of significance with 10 degrees of freedom. So again, we can just use a chart. So this one says we want a right-tailed test. So let's look at the chart. This is the area in the right tail. So this is the t distribution. So remember, the t distribution was the one that wasn't symmetric. It just depends on the degrees of freedom. The bigger it gets, it starts to follow normal, but most of the time I just use this skew to the right example. So the area in the tail would be here. If we did a left tail test, it would be over here somewhere. But it's not going to be symmetric like the normal that we have been dealing with. So right tail test, we were looking for alpha 5%, 10 degrees of freedom. Okay, so we're going to go down here, degrees of freedom 10, alpha 5%. So right here, 0.05. We're looking at 1.812, 1.812. Positive 1.812. All right, B, critical value, left tail test, mean at the alpha equals 0.05, level of significance based on a sample size of 14. So remember, when you have sample size, you get your degrees of freedom. Degrees of freedom is n minus 1. So if we have sample size of 15, we would do 15 minus 1, and that would give us 14. So we're looking at 14 degrees of freedom, left tail test. So this time it's going to be a negative number because we're dealing on the left side. .05, 14, 1.761. All right, and then C, critical value for a two-tailed test, 10% level of significance based on n equals 14. So this one means 13 degrees of freedom. 14 minus 1. Your alpha is 10, but you got to divide that by 2 because we're looking at two sides this time. So that means 0.05 is going to be in either side. That's how we get our 10, two sides. 5 plus 5 gives us 10. And then we just need to find that value. So plus or minus, we're going to have a positive and negative value. 5%, 13 degrees of freedom right here. 13, 5%, 1.771.